Let me welcome you at today's video in which I'm gonna show you how to use the substitution method when solving logarithmic equations. And before I start, I want to say that this video is dedicated to my students from free AB class where I'm teaching this year, and especially to Marco and Veronica. These two equations, which you can see on your screen, are gonna be both solved by the substitution method, though the first one is a little bit, let's say, tricky at the very beginning because it looks scary, but as you will see later, it will be a really easy equation to be solved then by using the substitution method. And this approach is the point where you should get, I would say, almost always when you think about using the substitution method. So let me start with the first equation, which is 4 times log base 9 of x times parenthesis log base 9 of x, take away 1, close parenthesis, and this is equal to 2 plus 3 times log base 9 of x. So the first thing you should do when you see something like this is to get rid of the parentheses, and then you will get something like this: 4 times log base 9 squared of x. Please be careful because multiplication of these two terms, the first one in front of the parentheses and the first term in the parentheses, its product is not 4 times log base 9 of x squared, because this is really something different. As you can see, log times log is log squared, and it's not x being squared, but the whole function, in this case logarithmic functions. This notation can be also written, but I think you will not find this as a common notation of the fact which is written above, because I personally find it a little bit like not useful, but maybe for some of you it's gonna be more clear if you realize that these two expressions are equal. So let me now continue with multiplying, and the second term on the left side of our equation will be then take away 4 times log base 9 of x is equal to, there is nothing to be done on the right side of the equation, so it remains the same. And now we came to the equation where you can see that if you will use the substitution method, which in this case, let me take a letter A, that will substitute for us the expression log base 9 of x. So then, after using this substitution, our equation will be, as you will see in a minute, it's gonna be typical quadratic equation, which is easy to solve. It's much easier to solve quadratic equation than to solve directly the equation which was given at the very beginning. Now we will rearrange our equation so that it really looks like quadratic equation. So we will take away 3a and take away number 2, because we want to get rid of the expression on the right side of our equation. If we do so, we will get the quadratic equation, which is gonna be something like this. As you can see, this expression or quadratic equation cannot be solved very easily by finding two expressions which we will multiply and we will get very easy solution. So in this case I think the easiest and the fastest idea is to use the discriminant method for calculating this equation, which is b squared take away 4 times ac. But be careful, in this situation this letter a is not the same as this one, but it is the coefficient in front of the quadratic term. So our discriminant in this case is equal to negative 7 squared take away 4 times a is equal to 4 times negative 2, which means our discriminant is equal to 49 plus 8 times 2 is 16. So our discriminant is equal to, it is 65, which is not a nice number. So I'm pretty sure there is something wrong with my equation, because I would expect that the solution should be something which is really much nicer. So the question is, where is the mistake? Let me just check very quickly if I can find it. And okay, the thing is that 4 times 4 is not 8, but it is 16. So 16 times 2 is 32, and this is something which I like much more than the previous result, because our discriminant is equal to 81, which is a nice number, because we know we can calculate very easily the square root of 81, which is 9, and it is gonna be used when we'll try to find the roots of our quadratic equation. So a1, a2, which is the solution of our quadratic equation, should be or are equal to negative b plus minus square root of discriminant over 2a, which means that this is equal negative b, which is negative 7, negative 7, which is definitely positive 7, plus minus square root of 81 is equal to 9, and 2 times a, which is 2 times 4, and this is equal to 8. So it means our roots, let me just do it this way, a1 is then equal to 7 plus 9, which is 16, over 8 is definitely equal to 2, and a2 is equal to 7 take away 9 is negative 2 over 8, which is negative 1 over 4. So as we have the solution of our quadratic equation, we have to do the substitution, which means we already know the value of the a from this equation. So we will replace letter a or unknown a with positive 2, which means then 2 must be equal to log base 9 of x, which means that our solution is x being equal to 9 to the squared. This fact is well known, because this is the definition of the logarithm. So our first root is equal to 81. Our second root can be found such that we will replace now our unknown a with negative 1 over 4. This root is gonna be a little bit tricky. In this case I'm gonna switch the sides, or swap the sides of our equation, because then it would mean that log base of 9 of x is equal to negative 1 over 5, which means that our x is then equal to 9 to the power of negative 1 over 4. This result is, let's say, a little bit tricky, but for those of you who are okay with this result, you can leave this as really the result of the equation. But on the other side, I want to show you how to get, let's say, better number for checking the solution of the given logarithmic function. So x is equal, and 9 can be written as 3 squared, and this to the power of negative 1 over 4, which can be simplified based on the rules with exponents, that this is 3 to the power of negative 2 over 4. You can simplify the fraction even if it's in the exponents, so this is equal to 3 to the negative power of 1 over 2. As there is negative power, it means you can write your result as 1 over 3, the whole expression to 1 over 2, but as there is number 1 in the numerator, it's not necessary to write it this way. You can see that our fraction can be written like 1 over 3 to the power of 1/2, but this is definitely equal to 1 over square root of 3. But as we know, the good manner is to remove the square root from the denominator of this fraction, which can be done by multiplying the number 1 over square root of 3 with number 1, and number 1 can be represented with this kind of fraction, and then you will get the result square root of 3 over 3. Now the question is, why is it important to have the number this way? Probably the answer is that before you start to solve any logarithmic function, you have to think about the conditions or about the domains of all the logarithmic functions which are presented in your equation. And in this case we are, let's say, lucky because there is only one logarithmic function, and it is log base 9 of x, and as we already know, the domain of such a function, or the function, is defined if and only if the argument is greater than 0. So as you can see, our argument should be greater than 0. Both our roots are greater than 0, so they fit to the condition and should be, and of course they are, the solution of the first logarithmic equation. What I want to repeat and want to say is that if you see, and this is like the very common and very basic logarithmic equation, if you have a look at, you should start thinking about using the substitution method, because this method will lead you to the equation which can be solved very easily, in this case quadratic equation. Okay, I think that's all for this equation. Now let's have a look at the second equation, but let me check if I have enough space here. Yes, so I will move this one a little bit down, or at the bottom of my screen, and then now let's solve this equation. Again, this is kind of typical equation which when you see this kind of equation, you should start thinking about using the substitution method, because to play around with this, you can get rid of the fraction on the right side of the equation, like here, directly by multiplying the equation with the denominator of your fraction. But sometimes it is easier for some of you, like my students, to realize that you have on both sides of the equation the same log function, and one of them is really in the denominator. So you can start with the substitution method right here and replace the expression log base 5 of 2x plus 3 with some, let me say, new defined variable. And when you use such a substitution, then your equation will be easier, and maybe in this situation you can see easily that this equation is some kind of equation you are supposed to be able to solve. So to solve this equation, you just multiply both sides of the equation by a, so you at the end get rid of the a in the denominator of the fraction, and this will lead you to the equation a squared is equal to 4 times a take away 3, and this is again a very easy equation f. This is quadratic equation, and now let's get rid of the expressions on the right side of the equation by take away 4 times a plus 3, and you will get a squared take away 4 times a plus 3 is equal to 0, which is really a simple quadratic equation to be solved. I will solve this for you, but before I do so, I want to say here and show you how you can get to the same equation by not making the substitution method at the very beginning, but by multiplying this equation. Let me just write it again. Log base 5 of 2x plus 3 is equal to 4 take away 3 over log base 5 of 2x plus 3. As this is equation, we can really multiply the equation right here by the expression log base 5 of 2x plus 3, and you will get something which we were solving in the equation before. Log base 5 squared of 2x plus 3 is equal to 4 times log base 5 of 2x plus 3 take away 3. And now, as you can see, if I would provide the substitution here, so I will replace the log base 5 of 2x plus 3 expression by new defined unknown a. It is gonna be a squared is equal 4 times a take away 3, which is exactly the same equation we have here. So the decision is which method or which approach to take is up to you. I would prefer probably to take the first approach, but the second approach is very nice also, and as you can see, both of these approaches will lead you to the same equation, which now should be solved. And this quadratic equation is very nice because it can be solved very easily by factoring, which means a take away 1 times a take away 3 should be equal to 0, because if you would factor these two expressions, you will get the expression above. And now, as you can see, a1 should be equal to 1 or a2 should be equal to 3. These are the roots or solutions of our quadratic equation here, but as we did before, the same procedures should apply. So we do the resubstitutions, which means 1 must be equal to log base 5 of 2x plus 3, or 3 must be equal to log base 5 of 2x plus 3. Now from the first equation we will come to the equation that 2 times x plus 3 must be equal to 5, because 5 to the power of 1 must be equal to the expression or the argument of the function. And if you solve this equation, you will see that 2x is equal to 2, so our first root is equal to 1. The second root can be found or is found the same way like in the first case, so 2x plus 3 should be equal to 5 to the power of 3. So 2x plus 3 is equal to 125, and 2x is then equal to 122. Now if we multiply both sides by 1/2, x is then definitely equal to 61. There is one thing you have to think of and not forget, is to find the conditions where our logarithmic equation is defined, and in this case there is a logarithmic function, and the logarithmic function is defined if and only if the argument of the function is greater than 0. So in our equation it means that 2 times x plus 3 must be greater than 0, which means 2x must be greater than -3, so x must be greater than -3 over 2, which is definitely -1.5. And as you can see, both our roots, x being equal to 1 and x being equal to 61, meets the condition, so these are definitely my solution. So if you want to be like really precise, you can write that x is from the two element set, and the first element is number 1 and the second element is number 61. Okay, so this is basically everything you should know about solving logarithmic equations by using the substitution method. As you see, the main advantage or the main goal for using the substitution is to get rid of, let's say, very tricky equation which solution can be found like very hardly, or could be, as I said, really tricky, and this substitution always or more often or very often leads to the quadratic equation, and we are able to solve this quadratic equation very easily. But please don't forget then to do the resubstitution, and also please don't forget to find the domain of all logarithmic, let's say, functions or expressions which are given in your equation. Okay, so thanks for watching. I hope you will find this video useful, and please do train as much as you can. See you and hear you during our next video. Bye.